Hello students, welcome to Vihira Academy. I am your educator Dr. Hina Devnani and today we are going to study chapter number 10 of 10th standard science. The name of the chapter is Light, Reflection and Refraction. Now before moving into the chapter, let us first understand what is light. Light is actually a form of energy. It is an electromagnetic wave. Light is responsible for us to see various objects that are present around us. If you enter in a dark room, will you be able to see anything in it? No. But if you turn on the lights, you'll be able to see all the objects that are present in it. Now, how do you see those objects? The phenomena that occurs here is when light falls on the objects, the object reflects that light. And this reflected light then reaches our eyes, and so we are able to see the objects. So we can say that light is an electromagnetic wave which is responsible for sensitizing our eyes. Our eyes are sense organs that are responsible for vision, and we can see things. The things become visible to us only because of light. When light falls on the objects, only then we are able to see the object. An important characteristic of light is light travels in a straight line. Now there are many phenomena that occurs related to light, such as formation of shadows, formation of images by certain mirrors and lenses, bending of light in a medium which is called as refraction, twinkling of stars, formation of rainbow and many other phenomena. So some of the phenomena we are going to study in 10th chapter and the remaining we'll be studying in 11th chapter. First of all, we'll start with a basic phenomena of light which is known as reflection of light. Reflection of light simply means the bouncing back of light. As I said that when light falls on an object, the object reflects that light. So here also what happens? The light is actually bounced back by the object. So when the object bounces back the light, we can say that the object has actually reflected the light. When light falls on a highly polished surface like a mirror, then this light or most of the amount of this light will be sent back, and that process is known as reflection of light. As you can see here in the image, the sun's light is falling on the tree. The tree is sending back that light again into the medium, and the observer is taking that light into his or her eyes. And by this method, the observer can see the tree. So this is a very simple example of reflection of light. As I said, reflection of light is a very important phenomena of light. So it has two laws which are considered as laws of reflection of light. First law is angle of incidence is always equal to angle of reflection. Now as you can see here that the light is coming towards the object, and this light comes with a certain angle. Then the light will be reflected again, and the light is reflected with another angle. So the angle which comes when the light is incident on an object is known as angle of incidence, and the angle formed when the light is reflected is known as angle of reflection. So the law of reflection says that angle of incidence will always be equal to the angle of reflection. That is the first law of reflection of light. Second law of reflection of light says that the incident ray means the ray which is coming towards the object, the reflected ray, that means the ray which is reflected back, reflected ray of light, and the normal is a perpendicular which is drawn at the surface of two media. Like suppose the light is coming from air and it is reflecting or it is getting reflected by mirror. So the point where mirror and air are connected, at that point we draw a perpendicular. This is completely an imaginary line. So this completely imaginary line is called as normal, and it is always perpendicular to the surface where two media are connected. So the incident ray, the reflected ray and the normal lie at the point of incidence, and the normal that is drawn at the point of incidence lie in the same plane. So these are the two laws of reflection. First law, Angle of incidence is equal to the angle of reflection, and second law, incident ray, reflected ray and the normal, they all lie in the same plane. In your lower standards, you all have studied image formation by a plane mirror. So most of you might be aware of the characteristics of the image that is formed by a plane mirror. A plane mirror is the common mirror that we use at our houses. What is the characteristic of the image that is formed by a plane mirror? First of all, the image will be erect. The image will be of the same size as that of object. The image is at the same distance from the mirror as the object is in front of it. You can see here, this is the object and this is the image. The object is kept straight. The image is also erect. Here you can see the distance between the object and the mirror is similar to the distance between the image and the mirror. The image is virtual. That means this is not real. This cannot be obtained on a screen. It is a virtual image. And it is laterally inverted. Now what is the meaning of laterally inverted image? Let me give you an example. Suppose if you look yourself in a mirror, you will observe that your right hand will appear to be left hand in the mirror and your left hand will appear to be right hand in the mirror. This is called as lateral inversion. So the image is erect but it is laterally inverted. Now we are going to start our main topic here, that is spherical mirrors. We have studied plane mirrors, but in this chapter and in 10th standard we'll be studying about spherical mirrors. Now what is this spherical mirror and why it is called so? As you can see here in the diagram, a C-shaped mirror has been shown, a concave and a convex. This is a C-shaped mirror and you have to imagine that this has been cut from a sphere. Let's consider here a sphere and this portion is cut from that sphere, from a hollow sphere. That's why this is known as spherical mirror. Spherical mirrors are of two types. First is the concave mirror and second is the convex mirror. If the reflecting surface is curved inwards, see here you can see it's written inner reflective. That means the inner area is reflective and the outer area is opaque. It is polished. So when the inner area is reflective, it is called as concave. And when the outer area is reflective, it is called as convex. The inner area is polished over here and the outer layer is reflective. So there are two types of spherical mirrors, concave mirror and convex mirror. Now before studying image formation by spherical mirrors, we need to understand certain terms that are used in optics. Now these terms are related to the image formation and these are used in mirrors. The first term is center of curvature. I'll show you the diagram over here. See, suppose if this is your lens, this is your mirror, concave mirror. It has been obtained from a sphere. Here you can see a circle has been drawn. This circle shows the sphere. Now the center of the sphere is center of curvature. So first term is center of curvature, which is actually the center of the hollow sphere. And here you have to note one thing, that this center of curvature is not a part of concave mirror. It's outside the concave mirror. Second is radius of curvature. Radius of curvature means the area or the distance from this center of the curvature, that is center of the sphere, center of curvature, to the midpoint or the center of the concave mirror. That distance is called as radius of curvature and it is denoted by a capital R. Center of curvature is denoted by a capital C. Now this point, the center of the concave mirror, is known as pole. You can see here it is marked over here. This is known as pole. It is denoted by a capital P. An imaginary line is drawn from the center of the concave mirror and it touches the pole and center of curvature. This imaginary line is called as principal axis. So these are the four terms that are used in mirrors. Center of curvature, that is the center of the sphere. Radius of curvature, that is the radius of the sphere. Pole, that is the center of the spherical mirror. and principal axis, which is an imaginary straight line passing through the center of curvature and pole. Apart from these four, two other important terms are used. First is the principal focus. The principal focus for concave mirror and convex mirror is different. What happens here? When rays of light touch the reflecting surface, they get either converged or diverged. Converged means all the rays will meet at a point in front of the mirror, and diverged means the rays will go away from the mirror and then they will be extended backwards. So either there will be converging or diverging. This we are going to study later on. For now, you just have to remember that all the rays after reflection will meet at a point to form image, and that point is known as principal focus, which is denoted by capital F. Capital F, principal focus, is the point where all the rays meet or appear to meet after reflection. It can be either concave mirror or convex mirror. In concave mirror, all the rays of light will meet at focus, and in convex mirror, they will appear to meet. So this point where all the rays of light meet or appear to meet is called as principal focus, which is denoted by capital F. Now the distance from capital F, that is principal focus, to pole is considered as focal length, and focal length is denoted by a small f. So these are the various terms that are used over here. Apart from all these terms, we use one more term which is known as aperture. Aperture means the distance from the ends of the concave or convex mirror. Here, this black line denotes the mirror. So the one end of this mirror is M and the second end of this mirror is N. So the distance from M to N is considered as aperture. For aperture, you can also write 2r. That means twice into the radius of curvature. You can see from C to M will be radius, again from C to N will be radius. So twice into radius of curvature will give us the distance of aperture. So these are certain important terms that are used while studying reflection of light through mirrors. Now, the most important topic of this chapter is image formation. Image formation by mirrors and image formation by lenses. So here we are going to study image formation by a concave mirror for different positions of the object. This table has been given in your textbook, and if you understand this entire table, you'll be able to write all the answers related to this question. Here what is given? Position of the object is given. It shows us where the object is placed. Position of the image is given, and then nature and size of the image is given. And for some, certain uses are also given. So let us consider this first. If the object is placed at infinity in front of a concave mirror, the image formed will be at the focus, that is at capital F. And this image will be real image, it will be inverted, and the size of the image will be diminished. That means point like. Let me show you the diagram. Here, the diagram A. You can see AB is the object. It is placed at infinity. Now, this AB object is reflecting light. So the light rays are coming towards the mirror, and because they are coming from infinity, these rays are parallel. You need to remember this. So these are coming towards the surface. From here you can see it is getting reflected, and after reflection they are meeting at a point which is capital F. This capital F is the principal focus. So the rays are meeting at capital F. And here you can see that the image is formed for the object AB, and this image is point like. You can see this is only a small point. So here the image formed is real, it is inverted, and it is point like. So you need to remember that if the object is placed at infinity, the image will be formed at focus, and this image will be diminished, real, and inverted. Now this is used as collector of radiation in solar heating devices. The radiations are collected from the sun. These radiations are focused at a certain point, and because of that only the heating devices get heated. Another example of this is when you try to burn a paper by focusing the rays of the sun. Now, if the position of the object is beyond center of curvature, the image will be formed between focus and center of curvature. This image will be real, inverted, and this will also be diminished, but it will not be point-like. Let me show it to you. Here you can see this is center of curvature, this is principal focus, AB is the object. So the object is present beyond center of curvature. It is not at infinity. It is present beyond center of curvature. These are the rays that are coming from the object. One is going downwards, one is coming here, and one is going here. Now when these rays are reflected back, they meet at a point between C and F. That means between center of curvature and principal focus. And they form the image over here. You can see A dash B dash is the image. Now this image is inverted. It is real. Why it is real? Because it is formed in front of the mirror. It is real, and this image is inverted and it is small in size. That means it is diminished but not point-like. Let's see third case. If the object is placed at the center of curvature, the position of the image will also be at the center of curvature. This image will be real, it will be inverted, and it will be of the same size as that of object. So let's see it by diagram here. AB is the object. The rays are coming from AB. They are coming to the surface of the mirror and they are getting reflected from here. You can see that this ray and this ray, they both are meeting here. That is at the center of curvature. And the image that is formed here is A dash B dash. This image is similar in size to the object. AB is the object and A dash B dash is the image. So image and object are of the same size. Fourth case, the object is present between the focus and center of curvature. So the image will be formed beyond the center of curvature. This image will be real, it will be inverted, and now the image will be magnified. That means the size of the image will be more than that of the object. Here you can see this is the reflecting mirror, this is center of curvature, this is principal focus. The object is present between center of curvature and principal focus. The rays are going towards the mirror, they are getting reflected and they meet beyond center of curvature. And they form an image which is A dash B dash. You can see the size of this image is more than the size of object. The image is inverted and real and magnified. Next case is if the object is placed at focus. The image will be formed at infinity. This image will be real, inverted, and it will be highly magnified. So here we can see the diagram. At F, the object is present, AB. It is going, the rays of light are going towards the mirror. These rays are then getting reflected, and you can see that these rays are not meeting. The rays are parallel. That means the image is formed at infinity, and this image is highly magnified. Now another case is the object is present between the pole of the mirror and the focus. When this happens, the image will be formed or it will appear to be formed behind the mirror. In all the 5 cases that we have done previously, we saw that the image was formed in front of the mirror. But now the image will be formed behind the mirror. And this image will be virtual because it is formed behind the mirror. It will not be inverted, it will be erect and it will be magnified. Here, the object is present over here between the pole and principal focus. The rays, they are going towards the mirror, they are getting reflected, and you can see they are going very far away. That means they are getting diverged. So we make them extend backwards and these appear to meet at this point, that is behind the mirror. Here you can see that the image is erect. Till now we have seen that the image was inverted, but now the image is erect. The uses are given here in the table. They are not given in the textbook, but still you can study the uses. Then we'll study the uses of concave mirrors. Concave mirrors are used in torches, searchlights, headlights to get parallel beams of light. They are used as shaving mirrors to see larger image of the face. The sixth case that we studied just now is for this use only, shaving mirrors. They are used by dentists to see larger images of the teeth. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Now we'll be studying image formation by a convex mirror. The table has been given in your textbook. Here the ray diagrams are also given. We can study. If the object is placed at infinity, where will the image be placed in a convex mirror? The image will be formed at the principal focus. As you can see here in this diagram, at infinity the object is placed. The rays will go towards the reflecting surface and they will be diverged. That means the rays are going outwards. What we have to do? We have to extend them backwards. And when we extend them backwards, we find that the image is formed at principal focus. Now you can see here that this image is point-like, similar to concave mirror. This image is virtual, erect, and it is extremely diminished. That means it is point-like. Second case, if the object is placed between infinity and pole. Between infinity and pole, it can be at any position, whether it is C, whether it is F. So the image will be formed between principal focus and the pole. You can see here, this is pole, this is principal focus, the image is formed here. But you have to remember that the image is formed on the backward side of the mirror, behind the mirror. This image is also virtual because the rays are not actually meeting, we are making them appear to meet. And this image will be erect and it will be diminished. So for convex mirror, we need to study only these two cases, whereas for concave mirrors, we have to study 6 cases. Now let us see what are the uses of convex mirrors. Convex mirrors are used as rear view mirrors in vehicles. Convex mirrors give erect diminished images of objects. They also have a wider field of view than plane mirrors. They are also used in magnifying glass and microscopes. So these are some of the uses of spherical mirrors, concave mirror and convex mirrors. Now another important topic is sign convention for mirrors. Whenever you are studying image formation or ray diagrams or anything, or if you are doing numericals related to mirrors, you need to understand the Cartesian sign convention. That means for what distance or for what measurement, what sign you need to use. Here what you have to take note, that in mirrors or whether they are lenses, the sign convention is similar to the sign convention used in graphs. In mathematics, we all use graphs, and when we make graphs, we know that what sign we have to use where, right? So let's consider this as a graph. This mirror, where the mirror is written, consider this as the origin. This will be your x-axis and this will be your y-axis. So in x-axis, on the right side of the origin, all the measurements are positive. On the left side, all the measurements are negative. On the upper side, in y-axis, all the measurements are positive. And on the lower side, in y-axis, all the measurements are negative. So same thing you have to take here. The origin of the graph will be the pole of the mirror. This one. The pole of the mirror can be considered as origin of the graph. So all the measurements or all the readings which are on the right side will be positive. On left side it will be negative. On the upper side it will be positive and on the lower side it will be negative. This thing is for concave mirror. The same thing is there for the convex mirror. Right side positive, left side negative, upper side positive and lower side negative. Now one thing that you have to remember here is focal length for concave mirror will always be negative because the focal length is on the front of mirror on the left side. And in convex mirror, the focal length will always be positive because the focal length is behind the mirror and it is on the right side. So this thing you have to remember. Rest everything will be similar to the graphs. Then we move to our next topic, that is mirror formula and magnification. To solve the numericals related to mirrors, you need to understand mirror formula. But before understanding mirror formula, we need to understand three important terms. First is V. V is also known as image distance. As you can see here, AB is the image. So the distance of A dash B dash is the image. So the distance of A dash B dash from the mirror is considered as V. V is the image distance. Whether it is concave mirror or convex mirror, in both of them V will be the image distance. U is the object distance. That means the distance of the object from the mirror. AB is the object over here, so the distance from AB to the mirror is U. Then comes F. Small f is the focal length that we have already studied. That is distance from the center of the mirror to the principal focus. Another thing that you have to remember here is H and H dash. H is the object height and H dash is the image height. Once you are clear with the symbols, you can easily solve numericals related to mirrors by using the mirror formula. This is the mirror formula. What is it? 1 upon V plus 1 upon U is equal to 1 upon F. That means 1 upon image distance plus 1 upon object distance is equal to 1 upon focal length. So you can easily find any of the three if the other two are given. Another phenomena that is required to solve the numericals is magnification. For magnification, you have to remember two formulae. One is magnification is equal to height of the image upon height of the object. Height of the image means h dash and height of the object means h. Or you can also write it as magnification is equal to minus v upon u. That is minus image distance upon object distance. Now, when you put numerical values over here, you need to remember the sign convention. You need to remember whether you are using a concave mirror or convex mirror. In concave mirror, all the three will be negative. In convex mirror, U will be negative whereas V and F will be positive. For height, in concave mirror, H will be positive, H dash will be negative. Whereas in convex mirror, both will be positive. So you need to remember the sign convention over here. So that was all about reflection of light and spherical mirrors. In the second part, we are going to study refraction of light. Till that, take care and keep studying.